Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are going to start a new topic on auditory senses and immersive experience. So, earlier we started our discussion with interactive systems, how they are important, how users' behavior characteristics are important to deal with interactive systems, to design better interactive systems, to design usable interactive systems. And in that context, we introduced the idea of human factors that influences the design and overall experience of interactive systems. The human factors that are relevant for extended reality systems, we had gone through basic ideas on those, and subsequently we started our a little bit more detailed discussion on individual human factors that are relevant for extended reality experiences. Previous lecture we talked about our visual senses, physiology of vision, and how that knowledge help us build better display devices or take design decisions when dealing with virtual reality experiences. In this lecture, we are going to talk about, in a similar vein, we are going to talk about auditory senses, our auditory sense, and physiology of our hearing, and how that is relevant for extended reality experience. So, essentially we will be covering basics of human auditory system and how they help create immersive experience in XR. In particular, our focus will be on VR, because VR is more relevant for immersive experience. So, first let us try to understand the role of audio in extended reality experience. If we think of it, generally when we talk of extended reality experience, immediately things that come to our mind are mostly related to our visual sense. And that is true with the developers as well. So, developers tend to focus mainly on vision, which is our strongest sense, so to speak, and most thought about sense. But vision is not the only sense that influence our experience with extended reality systems. There are other senses, we have already gone through those senses, 5 senses plus 1/6 sense, that is proprioception. We talked about those. So, one of those other senses is the audio or auditory sense. So, audio component of virtual reality is also very powerful in order to provide an immersive experience, and there are technologies that exist to bring high fidelity audio experience into VR, and if we make use of those technologies, then clearly our immersive experience will improve. Audio recording of sound, speech or non-speech sound, and reproduction, that is output generation, can be considered VR experience in itself, even if other senses are missing, and that experience can be relevant for both cave-like versions, that is the surround environment surrounded by display devices, where this audio recording and reproduction can provide better effect, surround sound effect, and even in headset version, that is wearable display version, there also the audio recording and reproduction can provide better immersive experience. In fact, when we combine sound with the vision or view effects, then that affect our perception about the virtual environment, such as size, volume, material, intensity, distance, and so on. Note that our general thinking is that just by looking at it, we will be able to get an idea of the distance or the size or the volume, material, and so on. That is partly true, the perception, the understanding of those properties of the objects that surround us gets reinforced when our vision is augmented with auditory effect. So, when we are trying to deal with immersive experience, our objective should be to include as many senses as possible. Only visual sense may not give us full picture of our surrounding. So, that will in a sense affect our immersive experience. If we augment vision with audio, that will enhance the immersive experience. So, essentially audio helps reinforce our experience as believable. That means, it is more closer to reality, more closer to our everyday experiences. It can help create emotional connect with the environment. Only vision may not be able to do that. Vision coupled with audio can increase our emotional connect with the environment. Overall, they are very important to maintain presence, because presence requires both reinforcement of our virtual experience as believable, as well as getting some attachment to that experience. So, overall auditory experience plays a very important role in increasing our presence in the virtual environment. So, that is why we should be concerned with generation of or dealing with audio in virtual reality experience. Now, like we did before for vision, let us try to first understand the basics of sound and human physiology that allows us to perceive sound, and then we will see how that knowledge can be useful for VR experiences, for designing better VR experiences. So, first let us start with the basics of sound. Most of us may already be aware of it, but like before, it is always better to recap our basic knowledge, so that subsequent discussions are understandable. Now, what is sound? Sound is nothing but vibration in a medium, and that medium is usually air, but could also be some other medium such as water or any other gases, liquids and solids. So, it requires some medium. Sound always propagates through a medium, unlike light, which may propagate without any medium as well. So, there is no sound in a vacuum, unlike light propagation, which can propagate through vacuum. Now, molecules in the medium gets displaced, causing variation in pressure, which is ranging from compression extreme, that is the pressure is extremely high, to decompression extreme or decompressed, that means the pressure is very less, that is also called rarefaction extreme. So, essentially when sound is generated, that creates pressure difference in different parts of the medium, ranging from compression extreme to decompression extreme, and that is the mechanism which allows sound to propagate through the medium. So, at a fixed point in space, that is within the medium, pressure varies as function of time. Now, the same is applicable in case of human eardrum. Pressure variation can be there on a human eardrum, which is converted into a perceptual experience, which we consider to be auditory experience. Now, this brings us to the representation of sound for better understanding. So, we can represent a sound in the form of a sound wave. So, which is nothing but a plot of pressure variation against time. So, as you can see in this accompanying figure, x axis represents time, y axis represents air pressure. So, as the time progresses, the pressure varies from one extreme to another, and it goes on like this, like a sinusoidal wave, and that representation we can consider to be representing sound. So, since we can represent sound as a wave, we can utilize wave properties to characterize sound. So, properties of sound as a wave, there are many such properties that we can utilize for various purposes. So, the first thing is frequency. Like a wave, sound can also be considered to have a frequency, which is number of alterations between one maximum to another maximum per second, which is measured in hertz. The unit is hertz. Now, human ear is designed to hear only a range of frequencies generated by sound waves, which varies from 20 hertz to 20,000 hertz. Anything between this range is audible to a human ear, and anything outside this range is not audible to a human ear. However, that is the limitation of human physiology, but other animals can perceive a higher range outside this audible range of human. So, that is frequency. Another property is amplitude, which is like any other wave, which is defined as the maximum displacement from the mean or rest position of the wave. It is measured in dB or decibel and measured relative to minimum sound detectable by humans at 1000 hertz. So, this is the second property, amplitude. Third is phase. It is the start position of a cycle of the wave, where it can begin at 0 to 360 degrees and measured in degree. So, we have primarily these three properties that are relevant for dealing with sound waves: frequency, amplitude and phase. Now, with that basic knowledge of sound, let us now shift our attention to the human auditory system or the physiology of human auditory system. Probably like before, we have encountered this in our high school days, the physiology of human hearing, but there is no harm in recapping the earlier knowledge. So, human hearing system contains three parts. Now, what are these three parts? Outer ear, middle ear and inner ear. So, we have three parts of human hearing system: outer ear, middle ear and inner ear. This part we can call up to this outer ear, then middle ear here and inner ear here. So, let us start with the outer ear. There are a lot of components in our auditory system. Crucial one is a canal. This canal works as an amplifier, boosting the sound pressure for a range of frequencies. So, this is the receiver part, and then it receives the wave, then forces it to propagate through the canal, which amplifies the wave, which is part of the outer ear. And because of the kind of fold that are there, the complex folds attenuates high frequencies. So, if there is some high frequency sound waves appearing, then due to the design of our canal and the receiver, the high frequencies get attenuated. Then comes the middle ear. So, once the wave passes through this canal, the outer ear, it then strikes the tympanic membrane causing vibration. This is the tympanic membrane. So, the wave hits this membrane causing the membrane to vibrate. Now, this vibration then transfers to 3 bones which are part of the middle ear, also known as ossicles, that are housed in air filled chamber, namely malleus, incus and steps. So, these 3 are shown here: malleus, incus and steps. So, these 3 bones are part of the middle ear. And finally, we have the inner ear. Now, this is the size of a marble which houses a component or an organ known as cochlea, which is the sense organ for hearing. This is the cochlea. This is part of the inner ear. Now, it converts sound energy to neural impulses. So, the cochlea is connected with nerves or neurons, and it converts the sound energy, that is the wave that is coming to it through the various mechanisms, to neural impulses to be transmitted to the brain through the neural network. So, in summary, what we can say is that in this part of the lecture, we have covered 2 important things, that is, why sound is important. Just to recap, most emphasis typically is given to our visual senses while dealing with virtual reality or any immersive experience. Visual senses are important, of course, and corresponding design of the display device is very important. However, to get a better perception of the virtual world, to have a higher presence, to get a better idea of the kind of objects that are there, their size, distance, orientation, position, volume, vision accompanied by sound always is preferable. And in that sense, we should think about including auditory stimuli to excite our hearing system, so that we get a better immersive experience. And there are already technology that exists to give us better immersive experience. Now, to understand how to do that, we started our discussion with basic idea of sound, which is nothing but a wave, and with this definition of sound as a wave, we can understand how our auditory system works. So, our ear contains 3 parts: outer ear, middle ear and inner ear. Sound wave gets converted to neural impulses through the mechanisms that are there in these 3 parts of the ear, and finally gets transmitted to our brain for perception. So, how ears are made, we have also discussed on those. In the latter part of the lecture, we will learn about how we perceive sound and how we render sound to get the best experience. So, we will continue our discussion in the next lecture. So, hope you are able to follow the lecture, understand the concepts. Looking forward to see you in the next lecture. Till then, thank you, goodbye and happy learning.